In this video, I will talk about one of the most important concept of finance, which is time value of money. We have few basic objectives, and number one is to know what is time value of money. Then we will see that there are two related terms, present and future values, and what are the relationship between these two terms. We will also see that how we can use the interest rate to adjust the value of cash flows both in forward and backward directions to single point in time. And briefly I will discuss about the difference between the compound and simple interest rate. There are a few important terms. Number one is present value, number two is future value, number three is discount rate or interest rate, n will be the number of time periods, and SI is the simple interest and CI is the compound interest. So if someone will give you the option to select among these two, from these two, one is whether you can get 10,000 today or 10,000 5 years from today, what would be your reply? Yes, I think so. Most probably everyone will say that we need 10,000 today, rather 5 year here onwards. So no one wants to wait for 5 years to get the same 10,000 if they have to select from these two options. And why this is the reason? The main reason is this, that 10,000 has the opportunity to earn the interest if say you will put in the bank today. Thus, time is a key element in the value of money, because over the period of time, the invested money, which in this case say 10,000, if you will be able to invest that 10,000 in the bank today, will be able to earn the interest over the period of time. So if you see this graph, this is very interesting graph. You can see that if you invest $25,000 at 8% interest rate, so after 20 years, that 25,000 will grow to $116,523 almost. And after 40 years, 20 years more, it will grow to $543,113. So you can see there is an exponential growth. It's not a linear relationship, right? So within the same 20-year time period, this 116,523 simply did not double. In fact, it increased much more to 543,113, because interest now which you are earning over the period of time, they have the opportunity to earn the interest on itself. This concept will be very much cleared in the next few slides. I'm giving you three alternatives and you have to choose only one of them. One is, do you want to get $100 today or $109 after 1 year, or $120 after 2 years? And say there is a guaranteed interest rate of 10%. So if you will get $100 today, there is a risk-free interest of 10%, which you will for sure get. So if that is the situation, which alternative you will go with? Whether you'll go with the number one, number two, which is $109 after a year, or number three, which is $120 after 2 years. So the best thing is, it's not only, if you'll see that go with the absolute value, then maybe your answer is okay, I'll go with $120. In that case, you might be thinking, am I losing something because I'm getting after 2 years, not right now? then yes, you losing something. And in order to have a best decision, the best way is to compare all these cash flows at single point in time rather at different point in time. So say if you are going with the first alternative, which is getting $100 today, and keep earning the risk free guaranteed 10% interest on that, see what will happen to this $100. So this $100 after a year became $110 because you earned 10% on this. So $100 you will keep your principal plus you earn $10 on that, which is the interest, right? So $100 becomes 110 after a year, and you can directly compare your now alternative, uh, like option number one, and the alternative investment, which is the second one of 109, that you are better off to go with the the first investment option. So 100 becomes 110. Now if you further grow this 110 and you keep having that in your bank, where your bank is giving you 10% interest, this 110 will grow to 121 because 110 multiplied by 1 plus 10% becomes 121. So additional $11 is your interest for the second year. So now here you can compare that the alternative option number one is much better than even the third one. It's 100 versus sorry, it's 121 versus 120 because 100 has grown to 121 versus 120. So you will basically use the interest rate to determine the cash flow at single point in time and then do the comparison with the other alternative, right? So this is actually the compound interest. Why it is the compound interest? If you see that in the first year the interest which you got is just $10, $100, and over here it's 110. So if you subtract 110 from the principal from the 110, you will get $10. That $10 was your interest. In the second year, this $10 which you earned as an interest in the first period become a part of the principal, and the second year interest is determined on this whole amount rather just the $100 which you got right now. So this is 110 multiplied by 100 and multiplied by 1 plus the interest rate, and this gave you 121. Now in case of simple interest, rather getting $11 interest in the second period, we will get again the same $10 in the second period as an interest which we have also gotten in the first period, because in simple interest we cannot get the interest over interest. Only in case of compound interest we can get interest over interest. So here we have the formula. After 1 year, 100 plus whatever the interest you got, which you will get by multiplying the principal, 100 with the 10%. So you got 110. In the second year, now you have 110, this one, plus 110 multiplied by the interest. So you will eventually got 121. If you do little bit of algebra, just take 110 common from here, you will have 110 into 1 plus the interest rate. And the journal formula for the compound interest is future value after nth period is equal to present value into 1 plus I raised to the power n. Now here there is a very related concept of present value and future value. Now this $121 is the future value 2 years onward of the present value of $100. So say this $100 you just got today, 2 years onward at 10% interest, compound interest, your this $100 becomes 121. So this 121 is the future value of $100, right? And this $100 is the present value of this $121, which you'll get 2 years. You will get in 2 years if you have the opportunity to earn 10% interest rate. So using this previous formula over here, which is the formula for the compound interest rate, where future value is equal to the present value into 1 plus interest raised to the power n, we can now calculate the future value after many periods. Because if we will not use this formula, then you have to grow this cash flow after each period, and with 2 periods it might not be that much an issue. But say if you have 7, 8 or 9 or 10 period, you cannot keep it growing after each period. We can directly use this formula to find the future value of this cash flow by the end of, say, ninth period. So let's see, over here we have an example. Say if you have a present value of 4,000, if someone has given you 4,000 and the bank is giving you an interest rate of 8%, what would be the future value of this 4,000 by the end of the 10th period, right? Over here we are taking the period as years, and the formula is the same, coming which we have discussed in the previous slide. So the future value of 4,000 in 10 years will be 4,000 into 1 plus the interest rate raised to the power number of time periods, where time period over here is a year. So there are 10 years. So the 4,000 at 8% will grow to $8,635.70 by the end of the 10th year. So again, this is a compound interest. Now if someone will give you an other scenario and will say that you will get $120 in 2 years, and you will earn the same 8% interest rate, but you need to put some value in your bank account today. So you want to know that should be that value in my bank account today, so that over the 2 years it will grow to 120. So you will end up getting 120 at the end of the second period. In that case, you will simply manipulate the compound interest rate formula and bring your this 1 plus I on the left hand side, where it becomes where it will go into the denominator. So if you do algebraic manipulation, you will end up getting present value is equal to future value divided by 1 plus interest raised to the power n. So here the future value is 120, and you want to know and determine its present value, that what cash you will deposit in the bank today, so that it will grow to 120 in 2 years with 8% interest rate. So if you will do this calculation, 120 divided by 1 plus 0.08 raised to the power 2, it becomes equal to $102.88. So this procedure and our process through which we determine the present value from the future value is called discounting. And when you have been given a present value, and like in the previous slide, and you were determining the future value, this procedure is called compounding, right? Because we are compounding the interest. Wrapping it up quickly, we have seen that time have effect on the value of money. And under the assumption, we have seen that if over the 10-year period of time at 8% interest rate, the present value of 4,000 will grow to a future value of 8,635 and 70 cents, and the future value in 2 years of $120 can be discounted back to the present value of $102.88 at 8% interest rate. There are much more complex concepts regarding time value of money, for example, the annuity, but those are not to be discussed in this video. And at some other point, I will discuss the concept of annuities in some other videos. Thank you.